Kita lihat the state of matter. So they exist as what? Only two states we have seen. Satu ialah keadaan pepejal, another one dalam keadaan gas sahaja. So across the period, so we can find them in a solid state dan juga dalam bentuk gas sahaja. Now, logam. Logam semua terletak di sebelah kiri. Like when you talk about logam, kita ada natrium, kita ada magnesium, and then yang ketiga ialah aluminium. Tiga ini adalah atom logam. The next is silicon. Silicon separuh logam. After that, everything from phosphorus until argon, semua adalah bukan logam. So metal on the left hand side are solid at room temperature, berada dalam keadaan pepejal pada suhu bilik. Dan juga dia memiliki, oleh kerana dia solid at room temperature, biasanya takat lebur dia dan takat didih dia sangat tinggi. That's why they are solid at room temperature. Another reason why their melting point, boiling point is very high, they are what we call a metallic bonding is very strong compared to van der Waals forces within the non-metal atoms here. Okay, itulah metal. Kalau non-metal macam mana? Start daripada silicon sampai argon adalah non-metal. They are normally on the right hand side of the periodic table. Dan di kalangan mereka, so kita ada gas lah kebanyakan. Ada yang pepejal, ada yang gas, the non-metals here. Like a pepejal, like a silicon, phosphorus, sulfur, tiga ini adalah dalam keadaan pepejal, solid state, while chlorine and argon exist in a gas state. So basically those who are in a gas state, they will have a low melting and low boiling point. Why? Because the intermolecular forces, daya antara molekul mereka sangat lemah. What's the name of the daya? Daya van der Waals. Okay, sangat lemah. Now, metallic properties, sifat kelogaman, baru saya sebut tadi. So going across here, we can find three types only. We can find metals, semi-metals, and also non-metals. Tiga keadaan ini. Dan yang metal ini, they have a very high electropositivity compared to the non-metal. But then, as I move from left to right, that means from sodium kepada magnesium kepada aluminium, the electropositivity decreases. Why decreases? Electropositivity maksud kecenderungan membentuk ion positif. So, untuk satu atom membentuk ion positif, they must eliminate the valence electron. So, the further the valence electron from the nucleus is much more easier to be eliminated. So, as I move from left to right, I realize that from sodium up to aluminium, the atomic size decreases. As the atomic size decreases, the valence electron, not outside electron, valence electron is getting closer towards the nucleus. When they're getting closer towards the nucleus, that means the nucleus is holding the valence electron much more strongly. When they're holding the valence electron much more strongly, difficult to eliminate them. So, jadi dengan arti kata lain, sodium lebih mudah membentuk ion positif berbanding dengan magnesium. Magnesium pula lebih mudah membentuk ion positif compared to aluminium. Alright? Okay, next. So, this means that the elements become less metallic because metal must form positive ion. So, of course, aluminium can form positive ion, but comparatively, so the metallic property is getting lesser and lesser. All right. So, one day when you study about A level or Form 6 or matriculation, you realize that aluminium, sometimes we cannot consider them as a metal. So, you learn this in higher level. For SPM, no need. Okay, now oxides of period 3. So oxides, as I said, very important, whereby we have three types of oxide. One, we call it as basic oxide, then acidic oxide. In between them, I have amphoteric. Okay, metals usually form metal oxide. Jadi semua metal oxide adalah basic oxide. All these like sodium oxide, magnesium oxide. These two are not only these two, but also other oxides as well, or other metal other than aluminium. but we are talking about period 3, so only these two are considered as the metals in period 3, sodium oxide and magnesium oxide. So these two metal oxides are known as basic oxides atau oksida base. Apa tu oksida base? Oksida base boleh membentuk larutan alkali bila larut dalam air. Alright, bila larut dalam air. Tapi keterlarutan mereka berbezalah. Like aluminium oxide mudah larut dalam air, so mudah membentuk larutan alkali. Magnesium oxide susah sedikit nak larut dalam air, so susah untuk membentuk larutan alkali. Okay, so ini basic oxide. Yang kedua, non-metal oxides will form acidic oxides. But like a carbon dioxide. Carbon is not, of course, they are not in period 3, but we can use a silicon oxide lah. So silicon oxide, sama dengan carbon dioxide, mereka merupakan acidic. So dari segi oksidanya, mereka merupakan oksida berasid. Okay, silicon oxide. Mana saya boleh dapat silicon oxide? Pasir, sand. Sand contain silicon oxide. So that means dia ada komponen berasid dalamnya dalam bentuk ikatan, like a phosphorus 5 oxide, sulfur dioxide, like a chlorine oxide. All this, semua oksida bukan logam akan membentuk oksida berasid. Manakala aluminium oxide, look at the formula Al2O3, very important. Formula dia katanya. Apa nama dia pun dia katanya, amphoteric. Let's go.